Hello guys, I'm Krishna and this is my first video that I'm doing on hydraulics and hydraulic machinery, and this is most important subject in the branch of civil engineering. And in this lecture I'm going to explain about the open channel flow. So before watching this video, please do like, share and subscribe to my channel. So let's start our video with open channel flow. So in general, open means what? Open means free surface, and channel means it's a way or passage. So by the simple context, you can get the definition of open channel flow. Flow in open channels is defined as the flow flow of a liquid with a free surface. Free surface is nothing but it is a surface having constant pressure, that is atmospheric pressure. So open channel flow can also be defined as a flow of a liquid under atmospheric pressure through a passage is known as open channel flow. In most of cases, liquid is taken as water. So this is about open channel flow. And let's discuss about the comparison between pipe flow and channel flow. In fluid mechanics, you might have learned about the pipe flow, and in hydraulics and hydraulic machinery, you will going to learn about the channel flow. In general, in pipe flow, flow occurs due to the pressure difference, and in the channel flow occurs is due to mainly due to the slope of the channel. In pipe flow, free surface is absent, and in channel flow, free surface is present. And if we consider laminar flow, if the Reynolds number is less than 2000, that flow is known as laminar flow. If the Reynolds number between 2000 to 4000, that flow is known as transition flow, that is in pipe flow. And if the Reynolds number is greater than 4000, then that flow is known as turbulent flow in pipes. And if you consider in channels, mm, if the Reynolds number is less than 500, that flow is known as laminar flow. If the Reynolds number lies between 500 to 2000, that flow is known as transition flow. If the Reynolds number is greater than 2000, then that flow is known as turbulent flow in channels. So you might got confusion regarding with the Reynolds number. So I will explain later in future. So next one, classification of channels. Classification of channels majorly occur in four types, that is based on shape, based on construction, based on cross-sectional area and bed slope, based on top surface. So let's discuss based on shape. The classification of channels based on shape mainly classified into four types, that is trapezoidal channel, rectangular channel, triangular channel and circular channel. And based on the construction of channels, the channels may be classified into two types, that is natural channel and artificial channel. Natural channel is nothing but it is having irregular shape and like natural channels are irregular in shape, and these are like rivers, streams, and these are naturally formed channels. Artificial channels are nothing but these are the man-made channels, and which can be built for the specific purpose, and based on cross-sectional area and bed slope. You can see based on cross-sectional area and bed slope, the channels can be divided into mainly two types, that is prismatic channel and non-prismatic channel. And prismatic channel is nothing but if the cross-sectional area of the channel is uniform and having bed slope is constant, that channel is known as prismatic channel. That means if the channel is having uniform cross section and slope is constant, that channel is known as prismatic channel. A non-prismatic channel is nothing but it is vice versa. that means opposite to the non-prismatic channel. That is, cross section is non-uniform and bed slope it changes. So that type of channel is known as non-prismatic channel. Next one, based on top surface. Based on top surface of the channel, the channels are broadly classified into two types. That is open channel and closed channel. Open channel is nothing but a channel having without any cover at the top surface. Top is known as open channel. That means when we consider the top surface that is having that is not covered with anyone anything, the type of channel is known as open channel. If suppose same if suppose that is covered with anything, the with anything, then the type of channel is known as closed channel. So this is mainly classification of channels. So next topic, types of flow in open channel. This is very most important topic in open channels. So mainly there are four types of flows in open channels. That is steady flow and unsteady flow. It is one type of flow. And next one is uniform flow and non-uniform flow. It's second type of flow. And next one is laminar flow and turbulent flow. This is another type of flow. And next one is subcritical, critical and supercritical flow. And this is another type of flow. So let us discuss one by one. Steady flow and unsteady flow. Flow characteristics such as depth of flow, velocity of flow, rate of flow at any point in open channel flow doesn't change with respect to time. This is very important. Doesn't change with respect to time. The flow is said to be steady flow. That means when we consider the characteristics like depth of flow, velocity and rate of flow is nothing but it is a discharge at any point in open channel flow that is not changing with respect to time. That means these flow characteristics are constant at any point. Then the type of flow is known as steady flow. That here we can observe the mathematical expression for the steady flow. That is dou E by dou T is equal to 0, dou Q by dou T is equal to 0, dou Y by dou T is equal to 0. Here V is nothing but velocity of, next Q is nothing but a rate of flow on discharge, Y is nothing but depth of flow. Next one, flow characteristics changes with respect to the time. Then the flow is said to be unsteady flow. It is quite opposite to the steady flow. And next one, here it is the mathematical expression for the unsteady flow. That is dou V by dou T not is equal to 0, dou Q by dou T not is equal to 0, and dou Y by dou T not is equal to 0. Here it means with respect to time, the above mentioned flow characteristics are changes. Then the type of flow is known as unsteady flow. So this is about steady flow and unsteady flow. Next one, uniform flow and non-uniform flow. Uniform flow is defined as the type of flow, and let's discuss briefly about uniform flow. For a given length of the channel, the velocity, depth of flow, slope of the channel and cross section remains constant. The flow is said to be uniform. That means suppose if we consider one length of the channel, that is here we can observe the uniform flow. Suppose this is the length of the channel, and if we consider the flow characteristics such as depth, velocity, and in this suppose this is the depth, this is the depth of the channel, that is D. If we consider same depth here over here, So depth may not be changes due to the uniform flow. And from here to here, if you consider not only the depth but also velocity of flow, if the flow is moving from here to here, the velocity is also same throughout the length. So this type of flow is known as uniform flow. Once again, uniform flow. For a given length of the channel, the velocity, depth of the flow, slope of the channel, and cross section is remains constant. The flow is said to be uniform. That means with respect to the length or space, we can say that is remains constant. That means flow characteristics such as velocity, depth of the flow, slope of the channel, these are remains constant. That means it doesn't change with respect to time. So this type of flow is known as uniform flow. And next one is non-uniform flow. Non-uniform flow is quite opposite to the uniform flow. If suppose we can take for a given length of the channel, the velocity of the flow, depth of the flow, etc. do not remains constant. The flow is said to be non-uniform flow. Do not remains constant means that is changing time to that is changing with respect to length. That means not constant. Here we can see the mathematical expression for the non-uniform flow. That is dou v by dou s is not is equal to 0. Here s is known as space or length. We can call it as length. Here dou y by dou s is not is equal to 0. Here y is nothing but depth of the flow. Here v is nothing but velocity of the flow. Note point. Non-uniform flow in open channel is also known as varied flow. So it is very important point. Non-uniform flow in open channels is also known as varied flow. So varied flow. What is varied flow? Varied flow is nothing but the characteristics. That means changes with respect to length. And varied flow is again classified into rapid two types. That is one is rapidly varied flow and another one is gradually varied flow. So let's discuss what is rapidly varied flow. Rapidly varied flow is nothing but suppose I will consider the length of the channel. My length of the channel, this is the length of the channel from here to here. So when the flow of fluid is occurs by changing its depth suddenly with respect to the length, so the type of flow is known as rapidly varied flow. If there is gradual increment or decrement in the length, then the type of flow is known as gradually varied flow. Rapidly varied flow means sudden change in the depth of the flow. So the type of flow is known as rapidly varied flow, and it can be denoted with RVF, rapidly varied flow, RVF. And gradually varied flow can be denoted with GVF, gradually varied flow. So this is about uniform flow and non-uniform flow. Next type of flow, that is laminar flow and turbulent flow. Laminar flow is the type of flow in which the fluid particles moves in a well-defined path or along streamline. So this is also known as streamline flow or viscous flow. Laminar flow is a type of flow. That means in laminar flow, the fluid particles moves in a particular direction. That means well-defined path or along streamline. So fluid particles moves along a streamline. So this type of flow is also known as streamline flow. Why? Because the particles moving in a streamline. So this is about laminar flow. Next one, turbulent flow. Turbulent flow is a type of flow in which the fluid particles moves in a zigzag way. That means irregular manner. irregular manner. Next one, turbulent flow is also known as mixed flow, and these are very important. And if the Reynolds number is less than 500, I have already discussed in introduction that in comparison between open channels and pipe flow, that is, if the Reynolds number is less than 500, then the type of flow is known as laminar flow. If the Reynolds number lies between 500 to 2000, that is known as transition flow. If the Reynolds number is greater than 2000, then the type of flow is known as turbulent flow. So majorly we can observe what is the difference between laminar flow and turbulent flow is nothing but laminar flow the fluid particles moves along in a defined path, well defined path. In turbulent flow, fluid particles moves in a zigzag way, and these are very important for competitive examinations. Reynolds number, and Reynolds number is denoted with RE. So it is about the Reynolds number. Reynolds number in case of open channels is, it is a formula for the Reynolds number. Reynolds number, I have already said that Reynolds number is denoted with RE. So RE is equal to rho V R by mu or rho V M by mu. Here rho is nothing but density of water, V is nothing but mean velocity of flow, R is nothing but R or M. These two are same. R is equal to M. Mu is equal to viscosity of, here mu is equal to viscosity of water. R or M is equal to, R is equal to hydraulic radius, or M is equal to hydraulic mean depth. These two are same, R or M, and this is formula for the hydraulic mean radius, and hydraulic radius is equal to cross sectional area of flow by wetted per meter. This is about the Reynolds number. And next one, subcritical, critical and supercritical flow. What is meant by subcritical, critical and supercritical flow? And these can be explained easily with by knowing the Froude's number value. And if the Froude's number is denoted with Fe, and if the Froude's number value is less than 1, then the type of flow is known as subcritical flow. If the Froude's number is equal to 1, then the type of flow is known as critical flow. If the Froude's number is greater than 1, then the type of flow is known as supercritical flow. Note: subcritical flow is also called as tranquil flow or streaming flow. This is very important. Subcritical flow is also known as tranquil flow or streaming flow. Next one, supercritical flow is also called shooting flow or rapid flow or torrential flow. Next one, Froude's number, formula for the Froude's number. Froude's number, I have already told that Froude's number is denoted with the Fe, and this is the mathematical formula for the Froude's number. Froude's number is equal to V by root GD. Here G is nothing but acceleration due to gravity, and V is equal to mean velocity of flow, and D is equal to hydraulic depth of the channel. And these two are not similar. Hydraulic radius, this is hydraulic mean depth, and this is hydraulic depth of the channel. Here R or M and D are not equal. So here it is a formula for the depth of the channel. Hydraulic depth of the channel. Hydraulic depth of the channel is equal to wetted area by top width of the channel. Wetted area can be denoted with A, and top width of the channel is denoted with T. So this is the end of the session, guys. I will make my next video on most economical sections. So thank you.